Welcome to Space Complexity lesson. In this lesson, we will explore space complexity, which is essential for understanding how much memory an algorithm uses. Just like time complexity helps us understand the speed of an algorithm, space complexity helps us understand how much memory is needed to run the algorithm. Common space complexities. O1. Constant space complexity. The algorithm uses the same amount of memory regardless of the input size. ON. Linear space complexity. The memory used increases linearly with the input size. O log n. Logarithmic space complexity. Common in recursive algorithms. ON2. Quadratic space complexity. The memory required grows quadratically with input size, often due to nested data structures. Real-world use cases. Space complexity is crucial when working with large data sets. Optimizing memory usage is important to avoid excessive consumption. Recursive functions. Recursive algorithms typically use more memory than their iterative counterparts. Examples of space complexity. Example 1. Constant space complexity, O1. This loop has constant space complexity, since it only uses a fixed amount of memory regardless of the input size. Space complexity, O1. Example 2. Linear space complexity, ON. The space complexity of this recursive function increases with each function call. Space complexity, ON. Example 3. Using memory-efficient data structures. Hash tables are efficient in terms of memory usage because they store data compactly and allow fast lookups. Space complexity, ON. Example 4. Optimizing memory with generators. Generators save memory compared to lists because they yield items one at a time instead of storing the entire list in memory. Space complexity, O1, for generator versus ON for a list. In this lesson, we learned about space complexity and its importance in optimizing memory usage. Key takeaways. O1, constant space complexity. ON, linear space complexity. O log n, logarithmic space complexity, especially in recursion. ON2, quadratic space complexity. Understanding space complexity is essential for developing efficient algorithms that can handle large datasets and optimize memory usage.